fairly simple. We want to know how to use formulas. Now, of course, in your earlier classes with pre-algebra, algebra 1, you spent a crap load of time already using formulas. Today is intended to be just a very, very quick review over using formulas. And since we're focusing on geometry, we want to use formulas for perimeter, area, and circumference. Right, so we have our list of vocabulary that we've seen and worked with. And so, just as a quick review, perimeter is the distance around the outside of the shape. Typically, you're going to get your perimeter by adding up all the sides. And so we have our perimeter and area formulas for three of the most common shapes that we'll work with. Rectangles, you can just add up all four sides for perimeter. Same thing with squares, you can add up all four sides. Triangles, you add up all three sides. Area of a rectangle, length times width. Area of a square, we know is side length squared. Area of a triangle, base times height divided by 2. Nothing earth-shattering. You've worked with all of them before. We're just having them here. One of the characteristics that I'm sure you've already seen before, and it's not something that I expect you to write down, but you are expected to know, base and height of a triangle are going to always form a 90-degree angle. Sometimes it'll be a 90-degree angle that looks like a T, sometimes it'll be a 90-degree angle that looks like an L. Depending on the kind of triangle, your height can be inside the triangle, can be outside. I'm sure you've seen a lot of them before. It's just a quick review, remembering you have to search for the T or the L to find base and height. Also remember, make sure you get your labels correct. With your earlier classes, I don't know how much your teachers emphasize having the correct label on it, but I am absolutely a stickler for it, because if all you do is give me an answer of 8, well, 8 what? Are you talking about 8 feet, 8 inches, 8 miles, 8 meters, 8 puppies, 8 jars of jelly? I don't know what you mean when you say 8 if you don't give me some kind of a label. So remember, perimeter as distance is always expressed with a linear label like inches, feet, miles. And area is square units, centimeters squared, meters squared. Don't forget your labels. Don't mess up the labels because they are important. Thus, we'll run through and get both the perimeter and the area. Which one did you want to do first? Okay, if we're going to get the area, what's our formula for the area of a rectangle? Length times width. And so we can simply plug in the length and width. What's the length of this rectangle? Okay, taking a length of 4, the width would then be 6. We'd have 4 times 6, giving us 24. But once again, 24 what? Inches, but that's not the right label. Area is not linear. Area is squared. So make sure you have inches squared. Let's also do the perimeter. How do you get the perimeter of a rectangle? Well, there are different formulas. The one that we had written down was 2 times the length plus 2 times the width. We're just still plugging in the values for our variable. We had just said length is 4 and the width is 6. So when we crunch those numbers, 2 times 4 gives us 8. 12 times 6, 12. 2 times 6 gives us 12. Adding those together, we get 20. Then where should the label be? Just plain inches. Okay, but what about if we have variables involved? How does the process change? It really doesn't. We'll still start off taking our formula. In this instance, 1/2 multiplied by base multiplied by height. Recognizing the correct formula to use, we then have to consider what are the base and height. How do you identify them? Once again, base and height are going to form a 90-degree angle. So where do you see base and height forming 90 degrees? Thus, we'll put them in. 1/2 base times height. And now we'll just start crunching our numbers. 1/2 of 6 is 3. And if we distribute across the parentheses, 3 times x, 3 times 4, we wind up with 3x plus 12. And what should the label be? Well, since it's area, it's obviously got to be squared. What squared? Feet, inches, centimeters? We are not given a label, and so we'll use the generic label of U, which stands for units. Whatever those units are, we don't know if it's in inches, we don't know if it's centimeters. Okay, what about perimeter? How do you get the perimeter of a triangle? We'll have to add together all 3 sides. Thus, we would have side 1 plus side 2 plus side 3. When we combine our like terms, 5x plus x equals 6x. 6 plus 4 gives us 10. And we're done. We cannot go any further because we don't know the value of x. All right, let's consider this one now. The Queen's quilt block, of course it's a quilting pattern, has 12 blue triangles. The base and height of each triangle are about 4 inches. Okay, so that's telling us the base is 4 and the height is 4. Find the approximate amount of fabric to use to make the 12 triangles. Which one is this? Is this an area problem or a perimeter problem? And how do you know? All right, so taking our area formula, 1/2 times base times height. We've got 1/2, 4 times 4. So 2 times 4, which gives us 8. And it's 8 square inches. Be careful though, because we're not done. That was the area of one triangle. We don't have one triangle. We have 12. What do we have to do to finish it off then? Let's take 12 times the area of one of them. And 12 times 8 gives us 96. All right, a couple other things to keep in mind. If we've got a circle, what's the diameter? Diameter is going to go through the middle all the way across. What's the radius? From the center to the side. What is circumference? circumference is the distance around the outside. Essentially, circumference is the perimeter of a circle. And thus, we have some of the circle formulas for circumference and area. All right, and then our last example. Find the circumference and area of a circle with radius 8 centimeters. Use the pi key on your calculator. Okay, so we'll make sure we have got our calculator handy. Oh. All right, so what's the circumference formula? 2 times pi times radius. And so we would have 2 times pi times 8. And we'll go directly to our calculator because we weren't asked to leave it in terms of pi. And so 2 times pi times 8. And round our answer to the nearest tenth. What do we have? .265, rounding to 1 decimal place, is equal to 50.3 centimeters. And when we do area, pi times radius squared, that'd be pi times 8 squared. So once again, we'll come back to our calculator. Pi times 8 squared. Round that to the nearest 10. We have 201.1. The 6 tells us to round up. And since it's area, we have 7 meters squared. And we won't go through and do the number crunching, but imagine for a second that this didn't say radius. What if instead it said diameter? How would the problem have been different if we were given the diameter? Well, how do you get the radius from the diameter? If you take the diameter and cut it in half, it'll give you the radius. So if the problem had given us the diameter, of course it didn't, but if it did, we'd simply cut the 8 in half. 8 divided by 2 would give us 4, and so we could put in 4 for a radius, 4 for a radius, and then just basically use different buttons on our calculator. Just have to make sure that we adjust it and use the correct thing in the formula.